So welcome to this blockchain special interest group presentation. So the topic is exploring AI agents on the blockchain. So we can see that there are quite a few of you here, so thank you for joining. There is a chat facility with questions and answers, so please feel free to discuss in chat and also to ask questions which can be answered later in the presentation. The presentation will be about 20 minutes. There'll also be a small demo. That's if the demo gods allow me to actually do a demo. I will do one and share my screen, and then we'll take questions thereafter. So in terms of content, we're going to look at defining what agentic artificial intelligence is. Then what we'll do is to look at solution architecture using mostly Amazon products, just to understand how to design and organize an agentic AI solution. And then we'll also look at a Coinbase agent kit, which a toolkit, which can also be used to develop agentic AI solutions. And then hopefully we'll be able to do a small demo, very simple one, but just to understand what agentic solution on the blockchain can do, but very simple demonstration. In terms of definition, I'm going to tell you by description what it is, because an AI agent perceives the environment, it makes decisions and takes actions to achieve specific goals. So it operates autonomously and it shows intelligence and adaptability. It uses large language model reasoning capabilities to understand, plan, act, observe, as well as reflect and learn. So this is not just a simple input-output model where you ask it a question and it gives you a response. It can take a whole workflow take many action steps, can reach out to other services, other pieces of information, and come back with a response. And if you respond back that it's not quite the answer you want, it will reflect, learn, and try to adapt to the situation as well. So very autonomous and has a fair level of intelligence. In terms of how they work, very simplistically, they gather information, they learn and analyze, they make decisions, and they take action. And furthermore, they can also get feedback, reflect, and also change the actions depending on the environment and the feedback that they are getting. So in terms of the blockchain, there are some specific uses for it, and it's mostly in the financial area. So in terms of automated financial management, so AI agents can take charge of finances and manage portfolios. Can also do efficient transaction handling, so can handle up to hundreds of millions of transactions simultaneously. They can be personalized financial assistance. AI will recommend services and take care of payments. Then in the decentralized finance space, they can help with automated liquidity management. So the agents can manage market conditions and adjust liquidity pools. So this is important for automated market makers that instead of an order book kind of handling of orders and tokens, they use automated market makers and adjust liquidity using smart contracts, and AI can help with that kind of automation as well. They can also help with executing trading strategies. So the agents analyze real-time data, identify opportunities, and execute trades. They can also optimize yield farming. So the agents evaluate farming opportunities and allocate funds to maximize returns. Yield farming is also a decentralized finance concept where you can take your tokens, say for example Ethereum, and put it into a platform, and it will give you interest-bearing tokens, so that they own governance tokens on the platform, and you earn interest using those tokens. And depending on the platform and what's happening on it, you can have various levels of yields, and artificial intelligence agents can help you find the best yielding farming instruments in terms of token yields. If we look at an AI agent and its capabilities, there are various levels of capabilities: basic, intermediate, and advanced. When we talk about Turing complete, we mean that the AI agent, if you give it a problem, it'll eventually find a solution to it if it has enough resources and time to do it. So on the basic level, it needs to be able to create a crypto wallet, Twitter messages, do text to image, token transfers, web searches, centralized exchange and decentralized exchange, being able to interact with APIs and do simple trades, multi-round dialogues both with agents and humans. It has to be pluggable and scalable so that it can be extended and also further increased in capability. On the intermediate level, non-fungible token generation. So this is for all the brand related kind of content where people want you to actually promote their brand using non-fungible tokens and that kind of capability. Then audio transcription, text to video. T stands for trusted execution environment. So when you're running code, smart contract code, you want it to be a trusted environment, and AI agents can assist with that. Then there's RAG and vector DBs are a form of storing information so they can be easily accessible by AI. So RAG is a special concept for calling that. And then there's a multi-agent system, character personalities, staking, smart contract auditing. So all those can be carried out by AI agents at an intermediate level. On the advanced level, you can have auto trading robots that can totally and autonomously do trades, reason, and find the best trades for you. You can create digital avatars and humanoid agents. You can plan and reason bottom up. You can execute smart contracts and autonomous gaming, non-player characters or NPC. So this is the kind of capabilities that AI agents have and also will possibly have in the future, and it's quite exciting what they may be able to achieve, given the right technology and platforms. So if we look at this simplistically, an AI agent is a large language model plus tools and plus logic. So if we could try and compare this to just a basic large language model that just accepts a single input and returns back an output, we can find the differences in this table. So in a basic LLM, you have a limited context window, but AI agents, they can manage and retrieve relevant information over time. So you can have multiple steps in this communication with it because it has the component of short and long-term memory. So basic LLMs have no external knowledge or capability of taking action outside of itself. AI agents, on the other hand, can access real-time data like pricing and interact with external systems like trading exchanges, for example. So the key components here are tools, which consist of APIs, web searches, code interpreters. So very, very powerful capabilities to be able to connect with the outside world. So basic LLMs have no persistent memory, but AI agents can maintain conversation, can have history and learn facts. So it has memory modules, and also some of them can store chat data in databases like SQLite, for example, or other databases. An basic LLM is fixed, single turns, input, output, but AI agents can execute multiple step plans, reflect, and replan. So there's the key tools there: orchestration logic, graph-based workflows, and control flow. I think in my one experiment with a AI coding agent called Replit, I asked it to create an application for me. It's a simple one, but what I found when it was running was that it was basically not refreshing the screen. So the screen would just disappear and all the inputs, values, and text would just disappear on screen. So I fed back to it that what was happening to the application, and it was able to fix it by itself. I mean, after a few iterations. So it's that kind of agentic AI capabilities that's quite powerful. Yeah. And then lastly, in basic LLMs, you have an inability to take action, whereas AI agents can perform real-world operations via tools. So it has key agent components of tools and action executors. I'm going to move on to something, a little bit more enterprise related, because, having AI agents and just doing simple prototypes or, asking ChatGPT for answers to some of your burning questions is useful. But the big question is, how do you safely introduce this into a enterprise architecture, or even a small enterprise, a large enterprise, or something that's already running as a business, has existing systems that you need to connect to, and you now want to introduce your AI agents into this type of environment. So there's like a 3-tier architecture framework. So this gives you a way to go about it, and also some terminology to understand how you would approach this. So on a tier 1 is the foundation level. Okay, so you have to like create security, data governance, and also some transparency around reasoning as a foundation layer, so that everyone feels safe and is secure, that no one can hack into your AI and its reasoning capabilities. The second tier is workflow, where you start building automation, so you can have different types of workflow patterns like prompt chaining, parallel processing, and orchestrator workers. And lastly is the autonomous tier, where you now give it more autonomy and allow it to make more decisions. So having dynamic intelligence, so goal-directed planning, adaptive learning, and multi-agent collaboration. So when we look in more detail, right, like in your tier 1 foundation, right, this is tool orchestration. So you want to have enterprise security, API gateway. So especially between your AI agents and your applications on the back end, say your databases, etc. You've got to have API security so that no one can hack into your back-end systems through your AI front-end agentic capability. You've got to have enterprise security, audit compliance, auditable, and then also risk management to try and reduce the risk of damage to your systems or reputation because of unethical usage of your AI agent. And then there's reasoning transparency, where you actually want to monitor your AI's responses, making sure there's no bias and that it is explainable and that you can build trust, because it's not so much about speed but trust, because you need to be able to understand how your agent is reasoning and coming up with its answers, and having that is more important than speed of execution. And lastly, there's data lifecycle governance. You must have your ethical safeguards, privacy protection, regulatory compliance. You have to conform to the rules of your jurisdiction that you're in. And there's also cost monitoring, because remember, calls to large language models do result in a cost, and if you're doing thousands of them in a day, it does add up. So you have to monitor these costs and make sure it doesn't overrun. If we move to the tier 2, which is workflow. So these are workflow patterns, and they're used to get structured autonomy, and it builds on the foundation level of security and governance. So you have things like prompt chaining, which is multi-step task workflows, and routing to different agents or different functions and APIs, and parallel processing, where a single task can be run in parallel to have efficiency and speed. Then there's evaluator, optimizer, which evaluates responses coming back and make sure that they are quite sanitized and they're not no biases and other ethical considerations being followed. There's also orchestrator workers which are responsible for resource planning and making sure that there's enough resources and that all your workflow tasks are running efficiently. So this is the orchestration and automation foundation as well. Then lastly is the autonomous level, where you have dynamic intelligence. So you have more goal-directed planning, ethical boundaries, multi-agent collaboration, and adaptive learning. But all this is built on that foundation of security, governance, so that you have a structured rather than a chaotic agentic AI implementation. And I mean, obviously, these are not easy steps to take, and it takes a great deal of work. However, if you want to introduce technology like this to an organization or some form of business, then need to have a little bit of security and governance so that everything is safe and that there's no reputational damage and that your systems work as expected. Okay, now what we're looking at here is a solution architecture, and this is more Amazon based, using Amazon technologies. So I'm not prescribing Amazon as a solution for an AI agent. It's just an example of how you would structure one and what kind of components that you would need, right? So if you see point number one is Amazon Bedrock guardrail. So this is the security layer, and it referred to as guardrails, trying to have a secure agentic AI. So things like input validation, output validation, and then stopping things like attacks on the AI agent, also social engineering attacks and those kind of things. So that base of security is run by Amazon Bedrock guardrails. And then point number two, you have a crypto AI supervisor agent that's based on Amazon Nova, which is their knowledge base. So a supervisor agent, one of its roles is to try and find the best agent to do a specific piece of work. So in a world of agentic AI, there's different agents with different foundation knowledge bases, and your supervisor has to find the right one to ask for work that it needs to be done. So in our case, it's going to call a blockchain data agent because it specializes in querying blockchain data and doing blockchain interactions. It also can call various APIs like get price on a crypto pricing API that connects to an exchange and gets the latest, for example, Bitcoin price. We look at point three, which is a knowledge-based news crawler. So this is about getting the latest information and news. So it's having a web crawler that goes out into the World Wide Web, picks up the latest blockchain information and stores it into a database for later retrieval. So this is important for getting like the latest news as to what's going on in crypto or what's the latest news in blockchain technology, etc. Then number four is, as we spoke about a little bit earlier, the blockchain data agent. So this is a specialist blockchain agent that knows how to query blockchain data using Amazon blockchain technology, and it picks up data from the Ethereum blockchain information and returns it back to the supervisor agent. And then number five is all about wallet management. So with wallet management, you want to be able to maintain your balances, be able to make payments, and also you have to be able to manage your wallet finances. And this is carried out using wallet management, and it's based on AWS Lambda for the calls to your blockchain endpoint. You also have AWS key management system, which controls your private keys, make sure that they are safe. So this is like a basic solution architecture. I mean, you can get much more complex than this, but this is something that can handle things like doing payments from your wallet. You can get news articles for you. It can tell you the balance on your wallet, and it can do a limited amount of perhaps automated trading as well, depending on the situation and what crypto you're trying to trade as well. So that's one solution architecture. What I found is that when looking at this, so Amazon uses a high level of security on, and to actually create a prototype based on this, you need to know the Amazon security system and how it sets up users and manages them. So it's quite a steep learning curve from that point of view. But definitely, if you manage to create something like this, it's very secure and very enterprise level. The next thing I looked at was a Coinbase agent kit. So this is a little bit easier for prototyping because it doesn't have all the requirements for setting up various security mechanisms, etc., which is it's okay for prototyping, but obviously if you want to productionize it, then you have to do a lot more work than just the simple prototype. So Agent Kit is a Coinbase developer platform toolkit, and it's for giving AI agents a crypto wallet and on-chain interactions. It is designed to be framework and wallet agnostic, so it can connect to basically any chain and any wallet that that is popular out there. AgentKit can also enable fee-free stablecoin payments and monetize AI agents seamlessly. In terms of functionality, it has on-chain actions, it has secure wallet management, framework flexibility, and multi-network support, so you can go out to many blockchain networks. Also has extensible design so that you can build on top of whatever the foundation layer is. So this is an example, like a solution architecture. So you, in terms of implementation, you can use various technologies, but what I'm showing you here is a simple Node.js server that that does server-side calls, and then a framework called LangChain, which is used for agentic AI. So it's good at doing things like workflows and graphs, right? And then at the bottom here, I chose to use the large language model of OpenAI. So again, I'm not prescribing any large language model. There's various ones out there. They're all good, but I think because of this was the one that I had heard about the most, so I just used that. And then there's also LangChain agents, and then CDP is the Coinbase Developer Kit SDK, and this allows the blockchain specific kind of functionality, because your large language model is it has a lot of information and knowledge and capabilities, but you need the specific blockchain interaction that is carried out by the CDP Coinbase Developer Platform SDK layer. So LangChain itself is a framework for developing applications powered by large language models. So you can design agents that can handle sophisticated tasks with controls. So you can use workflow and orchestration, and also a human in the loop to steer and approve agent actions. You can also evaluate your agent performance and quickly trace the root cause and debug issues. So it's a nice little framework for developing agentic AI. In terms of architecture, it has a core for base abstractions of chat models, integration packages. So this allows it to integrate to various large language models and databases. And LangChain itself it's built on top of LangChain core. There's a community portion, So that's more like community social networks like Discord, Twitter, etc. And then there's LangGraph for doing a graph interact, so storing chats and interactions in a graph type format with nodes and edges. That's also something that it's quite powerful at. When we look at OpenAI, it's a very popular large language model, and basically a user will ask us a question, the LLM will crunch a few answers in its AI brain, take some action, do some observation, and produce an output. And that's typically how they work. But then if you build things like workflow and graph-based interaction on top of it using LangChain, then you get a multi-step actions and reasoning capabilities and observation that that exceeds your basic large language model interaction, and that's what agentic AI tries to do. So the Coinbase developer platform itself is a suite of tools and services. So it's designed to simplify building on-chain applications. So it provides access to Coinbase's backend infrastructure and allows developers to interact with the blockchain in a secure, efficient way. So it offers APIs, SDKs, and pre-built components to streamline development. So that's the basic presentation. I think like the takeaway here is that agentic AI is quite it's quite powerful in terms of reasoning capability and being able to learn and adapt, and it consists of multiple steps, workflow, orchestration, graph-based interaction. And what I'm going to try and do now is to go into a little demo. So I just built very simple Coinbase toolkit application. So it's just little box that allows you to type in question and give you an answer about your wallet and certain things that's been set up on my Coinbase developer kit. So very simple, but just to show very simple capabilities of this kind of technology. So this is where I have to hand over to the demo gods, because I'm not sure what's going to go when I turn on my screen share. But please type in the chat if something really unusual happens. I'm going to share my entire screen, which could be dangerous, but here we go. So I can't see what anyone's chatting at the moment, but I'm hoping that everyone can see the screen. So I'm going to type a message. And so what's happening is so it's interacting with the large language model on OpenAI, and then it's connecting to the Coinbase developer platform, and it knows that I have a wallet and that there's some funds in it, so it's going to tell me how much I have. So this is obviously not real tokens. It's from a test net, so it's not real money, but it's just for demonstration purposes. So it's a very simple example, but it's able to tell me what I have in my wallet, and you can see instantly that it's different to other interactions with that you may have done in the past, because it can be very blockchain specific, and it can interact with what you have on your Coinbase developer kit here. So that's one demo. So I'm going to go back to my webinar jam just to see if there's any. Okay, that's good. Everyone saw the browser with Agent Kit, which is really good. So this here is my Node.js server running in the background. So it's running on localhost 3000, and it's got a little Node.js server, and that's the one that interacts with the OpenAI large language model, and interacts with the Coinbase Developer Kit program. So that's the basic demo. So it's very simple, but hopefully it just gives an idea of what this agent toolkit can do. You can obviously write very sophisticated AI agents. That was a very basic one, but hopefully it gives some form of motivation and interest in developing something of your own. Yeah. So that's more or less the end of the presentation.